Hi and welcome everyone. In this video, we are going to discuss the Liskov Substitution Principle. Let's get started with the definition. For Liskov Substitution Principle, subtypes must be substitutable with their base types. Now, in the world of object-oriented programming, we create classes for different entities and use inheritance among classes to describe a is-a relationship. What Liskov substitution principle says is that whenever you are creating a class hierarchy, the clients which are expecting a version of your base class to work with, if they are given a subclass instead, they should be able to get their work done without caring about whether the implementation they got was a base class or a derived class. If we have created a subclass which cannot be used in place of its base class, then that subclass is violating the Liskov substitution principle. Let's have a look at a couple of examples for LSP violation. So we are taking this shapes example. Here we have a base class called shape, which provides an interface for a client to draw a shape by passing an instance of shape class. Now, shape has two subclasses. We have a circle and a square. Okay, let's have a look at the draw shape method. If you observe closely, there's an open close principle violation as this method is explicitly checking for what shape instance it is getting and then calling the particular draw method for that particular class. The problem is that this method needs to be modified whenever there is a new class which is added to the shape hierarchy. Hence, this is not closed for modification, thus violating the open close principle. Interesting, isn't it? Let's have a look at how LSP is getting violated. Let's say we have a third subclass for a shape category called triangle. Think about what happens if client passes a triangle object to the draw shape method. What is the client expectation? A triangle on the screen. But what happens? Nothing. Which makes us think that triangle subclass is not substitutable in place of shape, which is the base class for the current method, thus violating the Liskov substitution principle. Let's have a look at another example. We have a base class called rectangle with two methods, setWidth and setHeight. And we have a derived class called square. Notice that the client is trying to interact with the base class and expects the base class as an argument. According to Liskov substitution principle, a subclass should be substitutable in place of base class. So let's see what happens when we try to pass a square. So after a square is passed, this method calls the setWidth method on the base class, and what happens is that the width is updated to 12. Think about this for a minute. Is this correct? If you observe now, you have square with uneven sides. That's not correct. Again, you see that you cannot pass a square in place of a rectangle. So these two classes are violating Liskov substitution principle. Let's see how we can fix this. If we add an override annotation to the methods in the derived class, now if you look at the previous example, if the client wants to call the setWidth method, even when the square is passed, the square remains intact. But look closely. You might be thinking that by now we have solved the LSP violation problem. But look at the new problem which arises. Client is expecting a rectangle and it set its height and width and tries to calculate the area. Whenever a rectangle is passed for this method, things are well. But what happens if you pass a square instead? With the new implementation, your method does not return the expected result. Why is that so? Since you are calling the setHeight and setWidth method not on a rectangle, but which is a square which is wrapped inside a rectangle as a subclass, when you call the setWidth method with the value 4, it also updates its height with value 4. And hence, when you try to get the area, you don't get it as 20, which is expected, but you get it as 16, which is 4 into 4. Now, with this new implementation, your method does not return the expected result. And you see how this square class is not substitutable in place of a rectangle. Hence, these two classes are violating the Liskov substitution principle. Do you see what the problem is? Even though you feel that a square is a rectangle, the design itself is incorrect because pragmatically, these two are not substitutable with each other. What is really happening in the two examples we have discussed so far is that if you observe closely, what the subclasses are doing to the client expectation is that they are causing some subtle side effects to the output. Like in case of square and rectangle, where set width did not update the height of the square and get area returned the incorrect area in case of a square. We should make sure that subclasses should be substitutable in place of base class, and to achieve this, we should always check that we are not violating any preconditions or post conditions for the base class which are causing the side effects. Let's see why the is a relationship is not working as expected. Even though we thought that a square is a rectangle, we were not able to substitute it. So let's see why. Whenever you try to think from an object's perspective, you might think that it is sufficient, but whenever you view something in isolation, it might seem correct. You should not view something in isolation or some classes in isolation. What you should do is look at how the client is going to use that. For that, you should design a contract. Now, this is where the LSP connects to the OCP principle. In open closed principle, we discussed that the classes should be open for extension and closed for modification. So here, if you have designed a contract for your client, then you have already solved one part of the problem. But Liskov substitution principle helps you to solve the other part of the problem, where you supply new subclasses for extending the behavior of the code. You should do that in a way that does not have any side effects with respect to the contract you have defined. Lastly, to keep your classes in check, you should add unit tests to keep track of all the pre and post conditions associated with your base class, which might or might not violate the contract. Okay, let's have a look at this more generic example to understand LSP. Let's say you are the client and your job is to reach the destination, and you're using an app which allows you to book a vehicle and get your job done, which is to help you reach your destination. Now, think closely. If you only care about reaching the destination, it doesn't really matter that you are taken by a car, a motorbike, or a helicopter, as long as you reach safely. Now, this is where Liskov substitution principle is in action. For this job, all the subclasses of the base class vehicle are capable of taking you to the destination, which means no matter which vehicle you substitute, your job is done. And in programming, the client class only cares about one thing: getting its job done through the dependency, no matter what the internal subclass implementation is doing that task. It simply does not care. As long as you are getting the job done, it's fine. Here are a few examples which can help you avoid Liskov substitution principle. The first one is to stick to your contract and make sure that you don't create side effects, as you have seen how these could affect badly your client's expectation. The second one is avoid degenerate functions. You might have seen your code where you provide an implementation for a method in the base class but keep the same method in the subclass empty. That can cause risk of substitution violation, since now you cannot use your subclass in place of base class. Third, if the user of base class don't expect any exceptions from the base class implementation, you should not throw any exceptions from the subclass implementation as well, as this would create uneven behavior. Lastly, avoid thinking on grounds of is or inheritance relationship. Think on grounds of is it substitutable for its client in place of base class. This will allow you to think more from the contract perspective rather than from the object perspective. Okay, now I hope that you have gotten a clear enough idea about what Liskov substitution principle is and what are some subtle conditions you should look for so that you don't violate it. And that's all with the Liskov substitution principle, and I will see you in the next video.